Signal is defined as any physical quantity or physical phenomena that conveys or carries information. Here, depending on the variation of the amplitude of the signal with respect to the time, the signals are classified into continuous time signals and discrete time signals. Here, this figure shows the amplitude of the signal varying continuously with respect to time. Therefore, it is referred as a continuous time signal. The continuous time signal is denoted by x of t and are referred as analog signals. Here, discrete time signal. Here, the amplitude of the signal is defined at discrete instants of time. Here, this figure representing a discrete time signal in which the amplitude or the values of x of n are defined at a discrete instance of time. It is a discrete time signal. The discrete time signals are denoted by x of n and the amplitude between these two time instants is undefined. Here, this discrete time signal is obtained by sampling the continuous time signal uniformly at regular intervals of time. Therefore, we can define it as the continuous time signal x of t sampling uniformly at regular intervals of time t equal to nt. Therefore, in mathematical form, it is expressed as x of n equal to x of t at time t equal to nt. Here, this figure is a digital signal in which the amplitude and time both axes are expressed in discrete form. These digital signals are obtained by performing sampling operation to the time axis and quantization operation to the amplitude axis. The next classification, it is based on the uh, continuity of the signal. Here, the signals are defined as periodic signals or aperiodic signals. Periodic signal means if one complete cycle of a waveform is continuously repeating with respect to time, it is referred as periodic signal. Suppose consider a square waveform, triangular waveform, square waveform, triangular waveform, sawtooth waveform, like that. If one complete cycle of the waveform is continuously repeating, then it is referred as a periodic signal. Here, in this periodic signal, a signal is said to be periodic signal if it satisfies the condition x of t equal to x of t plus t for all values of time, where capital T is the fundamental period. Fundamental period means it is the time period of the one complete cycle. Here, from this waveform, here in this waveform, this red color curve shows one complete cycle of a sinusoidal waveform, and its time period is referred as fundamental period, and its inverse is defined as fundamental frequency. Okay, the reciprocal of fundamental period is fundamental frequency, and here the units of fundamental frequency is hertz or cycles per second. Here, in angular frequency, the angular frequency measured in radians per second, and the relationship between the angular frequency and the fundamental period of the signal is described as omega equal to 2 pi by t. Suppose if one complete cycle of the signal does not repeats continuously, then it's said to be an aperiodic signal. Aperiodic signal means if x of t is not equal to x of t plus 2, if this condition is not satisfied, then the signal is said to be an aperiodic signal. Here, this figure shows, here one complete cycle is not repeating continuously, it is random in form, therefore it is an aperiodic signal. Here, this figure also, one complete cycle is not continuously repeating. Such type of signals are referred as aperiodic signals. Next, here even and odd signals. Here this classification is based on the symmetry property of the signal. The if the signal is symmetric about the origin, then the signal is then the signal is referred as even signal, otherwise it is any periodic signal. Here if you observe, this signal at the origin, the right side with respect to the origin, the right side portion is symmetrical to the left sided portion. That means the amplitude of the signal at right sided portion at a particular instant is same as the amplitude of the signal on the left side of the signal. That means the signal satisfies the symmetry property. It is an even signal. Here all these figures representing even symmetry. That means the curves are symmetrical at the origin. Therefore here a signal is said to be symmetric, an even signal, if it satisfies the condition x of minus t equal to x of t for all values of t. That means even signals are symmetric about the origin. Suppose here if the condition x of minus t equal to minus x of t for all values of t, then the signal is called asymmetric signal, odd signal. Here if you observe this waveform, here at t equal to pi by 2, the amplitude of the signal is 1, whereas at t equal to minus pi by 2, the amplitude of the signal is minus 1. That means x of minus t equal to minus x of t. That means at the origin the signal is asymmetrical. Therefore this type of signals are odd signals. Here odd signals are antisymmetric about the origin. Here the properties of even and odd signals are: even signals, for even signals odd part will be 0, and for odd signals even part will be 0, and the product of two even signals is an even signal, and the product of two odd signals is an even signal, and the product of an even signal and odd signal is an odd signal. The next classification is deterministic and random signals. Here a signal is said to be deterministic if it is expressed in terms of a mathematical equation. Otherwise it is a random signal. Here if the signal is expressed in terms of mathematical expression, at every instant of time the amplitude or value of the signal can be determined. Therefore such type of signals are deterministic signals. Here in deterministic signals there is no uncertainty or ambiguity with respect to its value at any time. Here that always the deterministic signals are specified by a mathematical equation. Some examples are x of t equal to at, x of t equal to a into sin omega t. Here like this mathematical expressions representing a deterministic signal. Here this is a ramp waveform, and this mathematical expression is x of t equal to at, where a is the slope of the line. If a equal to 1, and for every value of t, x of t value is linearly increases. That means if a equal to 1 and t equal to 1, x of 1 equal to 1. For t equal to 2, x of 2 equal to 2. Therefore as time increases the amplitude of the signal is linearly increases. Here this signal is a deterministic signal. Always its value can be determined for every value of t. Random signal, that means there is an uncertainty or ambiguity about its actual occurrence. Therefore example of a random signal is the noise generated in the amplifier of a radio or television receiver. This signal is, its amplitude is with respect to the time, its amplitude is randomly varying. Therefore we cannot predict the exact value of the signal at a particular instant with respect to a mathematical expression. Therefore, such signals are random signals. Causal signal. Here, causal signals. Here, these signals are sometimes the signal may present at time t greater than 0 with respect to the time axis, at time t less than 0, or it existing for time t greater than 0 and t less than 0. Accordingly, the signal is classified into a causal signal, anti-causal signal, and a non-causal signal. Here in this figure, the signal x of t is existing for time t greater than 0, and at time t less than 0, its amplitude is 0. Therefore, it does not exist. It is a causal signal. Here in this figure, the signal is existing for time t less than 0, and at time t greater than 0, it does not exist. Here we can say this signal is an anti-causal signal and its value is 0. That means x of t is equal to 0 for t greater than or equal to 0. Here in this figure, the signal is existing for time t greater than 0 and t less than 0. The signal is a non-causal signal. It is a non-causal signal. Here this figure presenting the three different types of causal, anti-causal, and non-causal signal. Causal signal means the signal existing for time t greater than or equal to 0. Anti-causal signal, the signal existing for time t less than or equal to 0. And non-causal means the signal existing time t greater than 0 and time t less than 0. Next, energy and power signals. Here, with respect to the type of the signal possesses some energy or power. Here, we classified the signal into a periodic signal or aperiodic signal. Periodic signals are infinite duration signals, whereas aperiodic signals are finite duration signals. Here, the energy signals means if the total energy of the signal satisfies the condition, if the total energy of the signal satisfies the condition greater than 0 and less than infinite, and its average power is 0, the signal is an even signal. The units of energy are joules. Here, with respect to a given signal x of t, the energy content of the signal can be determined by using the relations E equal to limit t tends to infinite integral minus t to plus t squared magnitude of x of t dt. In general, we can use the second and third relations also to determine the energy of the signal. Next, power signal. Power signal means if the average power of the signal, its values lies between greater than 0 and less than infinite, and its total energy is infinite, then the signal is a power signal and the units of power are watts. Here, the energy signals and power signals are mutually exclusive signals. And to determine the average power of the signal, here the relations on the equations 4, 5, 6 relations describe the average power of the signal. Now, periodic signals and random signals are power signals. Deterministic and aperiodic signals are energy signals.